About 90 minutes after you fall asleep, your body enters a biological paradox. Your brain activity surges to levels almost identical to when you are wide awake, yet your physical body is at its most still. To keep you safe during this intense mental activity, the brainstem sends signals down your spinal cord to completely paralyze your major muscles. This mechanism, called REM atonia, ensures you don't physically act out the intense simulations playing in your head. For over a century, thinkers like Sigmund Freud viewed this paralyzed state as a psychological theater, a way for the unconscious mind to express hidden desires or unresolved wishes that couldn't survive in waking society. Modern neuroscience reveals the specific chemical forces driving this state. This chart tracks the precise cocktail required for dreaming. Serotonin and norepinephrine, chemicals that ground us in reality, drop to almost zero, while acetylcholine rapidly spikes. Without norepinephrine to anchor you, your internal world takes total control. Next, the brain cuts power to the dorsolateral prefrontal cortex, the region responsible for logic, planning, and self-censorship. Your internal editor goes completely dark, leaving the mind free to generate impossible scenarios without ever questioning them. Dreaming represents a highly engineered, chemically induced state of physical lockdown. This deliberate vulnerability raises a significant question: what biological advantage makes the risk worth it? The answer begins in the brainstem. According to the activation synthesis theory, the brainstem fires off random electrical signals throughout REM sleep. The cerebral cortex receives these signals and attempts to force logic onto them. It stitches these random pulses together into a narrative, trying to write a script for a movie that has no plot. This disjointed storytelling reflects the visual interface of your brain's maintenance mode. While you sleep, the brain evaluates millions of bits of daily data, deciding what to keep and what to delete. Think of your brain as a librarian walking through a massive, disorganized archive. It is actively moving important information to permanent shelves and throwing out the daily clutter to prevent a mental hard drive crash. By playing back recent events inside these bizarre narratives, the brain physically strengthens the specific neural connections you need to retain new skills and memories. These logic-defying scripts represent the visual exhaust of a brain successfully organizing its files and optimizing your memory for the next day. This optimization extends into physical survival. Threat simulation theory argues that dreaming allows us to safely practice for dangerous situations in a secure environment. During REM sleep, the amygdala, your emotional center, is highly active. By simulating a threat, like a predator or a sudden drop, your brain trains your physical reflexes and emotional responses for real-world dangers. Nightmares function as a built-in alarm system, signaling that waking stress has overwhelmed your emotional baseline and needs attention. Parallel to this psychological rehearsal, a literal physical cleaning process begins. This diagram illustrates the glymphatic system. While you dream, your brain cells literally shrink in size, opening up wide microscopic channels. This allows cerebrospinal fluid to rush in and flush out toxic waste products like beta amyloid that accumulate during the day. The simultaneous shutdown of stress chemicals allows for overnight emotional therapy. You can process difficult memories and daily traumas without the intense physical sting of a racing heart or panic. Surviving a bizarre dreamscape means your brain is actively calibrating your survival reflexes, emotionally digesting your trauma, and scrubbing your neurons to prevent cognitive decline. The absence of waking logic allows the brain to make illegal connections between disparate ideas, often resulting in breakthroughs that the rational mind would miss. The chemist Dmitry Mendeleev struggled for years to find a logical way to organize the elements. His waking mind could not crack the pattern until he finally fell asleep. Free from the rigid rules of logic, his dreaming brain visualized this exact structural grid, translating an abstract thought into the actual periodic table. Today, researchers observe this identical phenomenon in machine learning. When artificial neural networks process massive datasets, they produce random associations classified as hallucinations, a machine version of human REM sleep. Looking to 2026, sleep science is moving into dream engineering. Using targeted memory reactivation, researchers are using specific smells or sounds during REM sleep to direct what a person dreams about, turning a passive biological process into an active tool for learning or emotional healing. Dreaming functions as an active, essential biological software suite. It deletes the noise of our daily lives, solves complex problems in the dark, and cleans our physical hardware to prepare us for the waking world.